Hello, I am Aditi Kumar and welcome to a very interesting learning session today, and it is related to the field of probability, and this is the first video related to the probability theory, and I am just planning to create a separate playlist for probability theory to dig dive into the different concepts under probability theory. So, especially today the concept I want to provide is a how probabilities is basically categorized into different areas, and whenever actually we are uh, thinking to solve the practical problem, then how we will basically adopt the mechanism or maybe appropriate solution from the probability theory, so that it will be very beneficial for us to identify the approach or what approach will be appropriate for our problem to solve in effective way. Let's start for today. First, I want to give some idea about probability. We understood from our previous mathematics and statistics related videos that probability is a field of mathematics especially dedicated to measure the uncertainty, because in the real world things are not simple, things are more stochastic and random in nature. So how we will frame our problem, our real world problem, into appropriate way, so that we can use the appropriate probabilistic technique to identify or maybe to measure the randomness correctly, so that we can take decision further in the correct manner. So I want to provide some top level, I can say some broad level categorization of the probability. Majorly I categorized the entire probability theory into three main subcategories. First one is classical probability, second one is empirical probability, third one is subjective probability. And the last two category I highlighted in different color here. One is prior probability and second one is our posterior probability. These two probability categories or maybe subfields are derived from the top three categories. These two categories specially derived from classical, empirical and subjective subcategory. So let's start for different categories one by one to understand more and more into it. First is the classical probability. It is the first category, and I can say it is also known as enumerative probability. The main foundation behind classical probability is here all the theoretical concept about our problem statement is known to us. Then we can think to use classical probability. What does it mean? For example, I am giving an example here. For example, I am rolling a dice. I can have only 6 options, right? Because there are 6 sides of a dice. I can only get one option out of these 6. Here the entire sample space means, here I am mentioning sample space means here I can say the total number of outcomes, possible outcomes. The entire number of possible outcomes is known to me. Like in the practical real scenario, the entire theoretical knowledge about our problem statement is known to us. Then we can think about classical probability techniques. Classical probability techniques means I can say counting, our mathematical concept, permutation, combination. These are the techniques we can think to use to solve our real world problem. This is basically the concept behind the classical probability. Let's go for next category. Second category is our empirical probability. So empirical probability here, it is experimental in nature. Why it is like that? It is also known as statistical probability. Why it is like that? Because in case of classical probability, the entire picture of the problem statement, for example, or the total number of possible outcomes, or maybe some theoretical knowledge about our problem statement in the real world is known to us. But here we don't know anything about our environment or maybe our problem statement. What are the number of possibilities? What is our theoretical knowledge about that problem statement? We don't know anything. It's completely stochastic in nature. It's completely, I can say, uncertainty in nature. Then we can think for empirical probability. Empirical probability is completely experimental in nature, and in the real world of data analytics and data science, there is a huge use of empirical probability, because whenever we will think about data driven solution, empirical probability is playing a very vital role behind each and every algorithm we are using. That's why I can say here one practical example I can say here. So a basketball player is making a free throw based on their historical performance, because here I can say we don't know what will happen in this event, right? According to the past history, we are doing experimentation and we are deriving the outcome. It might happen like this because something happened in the past, because using the past data we are basically doing some experimentation and we are deriving the output. And mathematical concept point of view, frequency, relative frequency, likelihood estimation, these type of techniques actually richly used in case of empirical probability. Let's go for third category, subjective probability. So subjective probability is basically there is not any certain rule, or maybe I can say certain formula for subjective probability. It's completely depends upon personal judgment or degree of belief. For example, Bayesian statistics is a type of statistic I can say, which is I can say it is coming under subjective probability, because in the Bayesian statistics, according to the one person's belief, so they derive basically one formula. It is basically used in society to solve the problem, and completely it is basically the personal belief. There is not any predefined formula or maybe certain criteria to justify that. So personal belief is basically in a manner they are doing some experimentation and deriving some result with a proving manner, so that definitely it is basically getting I can say accepted by the society and the further using to solve the real problem. Here example point of view, I can say a person believe in the likelihood of rain tomorrow. It is based on the appearance of the sky. Again, it is basically very person to person, right? I can think hey, it might be rain. Maybe another person will say no, it might be heavy rain tomorrow. It is completely depends person to person. Let's go for maybe next two category of the derived subfield of the probability, so that we can better understand these three categories, because these three categories are used there. These two categories are derived from these three categories. So first derived category here is prior probability. It is the combination of classical and subjective probability. That means we have the prior knowledge, we have the theoretical knowledge, and we have a personal judgment. If we are combining these two, it is known as prior probability, and this is the foundation of Bayesian statistics. We will basically we will have the different videos in future related to basic Bayesian probability and Bayes theory. So but here prior probability is the combination of two, classical probability and subjective probability. And if you are talking about posterior probability, then it is the combination of empirical and subjective probability. That means we are modifying our personal belief from experimentation. We are adjusting probability based on new evidence we are getting from experimentation. This is basically maybe I can say the foundation of Bayesian statistics. prior probability and posterior probability are two main part in Bayesian statistics. Let's summarize these 5 categories together. So I can say this is the classical probability, and this is empirical probability, and this is subjective probability. Whenever I am adding my prior knowledge with personal judgment, then we are deriving prior probability. Sometimes classical probability also known as prior probability, because classical probability and my personal evidence deriving the prior probability, the entire field of probability actually. And whenever we are combining empirical probability and subjective probability, personal judgment with experimentation with proof, because we don't have the knowledge, then it is posterior probability. And the entire picture is basically coming under the tree is a probability. It is very important to understand this concept, because if you will not understand this category, whenever we are facing a problem, we are going to solve a real world problem, we cannot take the appropriate decision. We need to think, for example, if something is some data, under this particular category, these are the conditions. If it is not satisfying, then definitely I will not go for this section of the probability. I will not think any approaches under this section. It will be very beneficial for us, very helpful for us to identify the correct approach while solving the problem in the real world. That's why I thought I will just provide a broad overview of the probability at starting, then maybe I will just create a different playlist with the more detailed concept of each part of the each section, maybe I can say. So thank you very much for watching this video, and please do subscribe my channel and put comment, so that in case of any doubt I can clarify. Also you can use my telegram channel to put any comment or maybe question, then I can also clarify there. Thank you once again for watching this video.